Abstract classes in Python, defined using the ABC module, allow developers to create blueprints for other classes. By declaring methods as abstract, you ensure that subclasses implement these methods, preventing runtime errors. This enforces a contract, enhancing code reliability and facilitating collaboration in large code bases by ensuring consistent method implementation across teams. In large code bases, ensuring subclasses implement required methods is crucial to avoid runtime errors. Traditional inheritance lacks enforcement, leading to potential oversights, especially in team environments. Python's abstract base class module offers a solution by defining interfaces and enforcing implementation contracts, shifting error detection to class definition time, thus enhancing code reliability and developer confidence. Abstract base classes, ABCs, are non-instantiable classes that serve as blueprints for other classes, defining a common interface. They enforce structural contracts, ensuring subclasses implement specific methods. This approach reduces bugs by catching errors at definition time, enhancing code maintainability and clarity for developers. The ABC module in Python is essential for creating abstract base classes. The ABC class allows your custom classes to inherit abstraction capabilities. The ABstract method decorator enforces that subclasses implement specific methods. ABC Meta, the meta class, underpins ABC functionality, crucial for advanced abstraction use cases. Mastering these components is key to effective abstraction in Python. The shape class, inheriting from abstract base class, serves as an abstract base class for geometric shapes. It defines abstract methods area and perimeter using the abstract method decorator. These methods establish a contract, requiring subclasses to implement them. Without these implementations, a subclass remains abstract and non-instantiable, ensuring adherence to the defined interface. Rectangle and circle classes implement the shape interface by defining both area and perimeter methods. Rectangle calculates area as width times height, and perimeter as twice the sum of width and height. Circle computes area using PR2 and perimeter as 2PR. These implementations satisfy the abstract class requirements, allowing instantiation and showcasing polymorphism. The triangle class, missing the perimeter method, triggers a type error upon instantiation. This error highlights the importance of fulfilling all abstract methods defined in the shape interface. Python's ABC module ensures that incomplete implementations are caught early, preventing object creation and enforcing adherence to the interface contract. The ABC module extends beyond methods, allowing abstract properties to be defined. This ensures subclasses implement essential attributes or computed properties. In the vehicle class, max speed and fuel type are abstract properties, requiring subclasses to provide these as properties, not methods. The decorator order, eProperty then iAbstract method, is crucial for enforcing this structure. Electric car and gasoline car classes implement the vehicle interface by defining max speed and fuel type properties. Electric car returns a stored attribute for max speed and a fixed value for fuel type, while gasoline car provides similar implementations. This flexibility allows subclasses to meet interface requirements while customizing internal logic. Abstract base classes can blend abstract and concrete methods, creating a robust framework. The data processor class exemplifies this by using the template method pattern. It defines a process, method for data handling, while subclasses must implement validate and transform methods. The save method provides a default implementation, ensuring flexibility and consistency in data processing. In payment processing, the payment processor class uses abstract methods to enforce validation and transaction execution. The execute payment method ensures a consistent workflow, validating payment details before processing and logging transactions. This design allows for custom implementations, supporting various payment methods like credit cards, PayPal, or cryptocurrency, while maintaining a unified process. The credit card processor validates payments by checking a 16-digit account number and positive amount, then charges the card. The bank transfer processor ensures a 10-digit account and amount under $10,000, initiating an automated clearinghouse transfer. Both processors inherit the execute payment workflow and logging from the base class, ensuring consistency while allowing specific implementations. Python's multiple inheritance with abstract base classes allows for complex interface composition. The UI component class inherits from drawable and resizable, requiring subclasses like button to implement both draw and resize methods. This approach enhances interface segregation and reusability, enabling flexible and maintainable code structures. Abstract class methods can be combined with a class method or static method decorators. In a factory class, the class method create is abstract, requiring subclasses like widget_factory to implement it. Similarly, validator uses static method for validate format, ensuring subclasses like email validator define specific logic. These patterns enhance flexibility in factory methods and utility functions. Python's ABC module allows virtual subclasses, enabling third-party classes to be treated as subclasses without direct inheritance. By registering a class like third-party class as a virtual subclass of serializable, ICE instance checks confirm its compliance. This approach supports duck typing while maintaining type checking benefits, especially useful for integrating legacy code or external libraries. Abstract base classes, ABCs, are essential for defining clear interfaces, ensuring multiple classes adhere to a contract. They're crucial in plugin architectures, strategy patterns, and framework development. In large team projects, ABCs act as documentation and enforcement tools, reducing integration issues. For library development, they offer clear extension points, guiding users toward correct implementations. Avoid over-abstraction by using abstract base classes only when necessary to enforce interfaces across multiple implementations. Start with concrete classes and introduce abstract base classes when patterns emerge. Always use abstract method for required subclass methods. Ensure correct decorator order. iProperty, class method, static method first, then iAbstract method, to maintain functionality. Abstract base classes, ABCs, introduce minimal runtime overhead, with abstraction checks occurring at class definition, not during method calls. Method calls perform like non-abstract classes. While ICE instance and ISUbclass checks are optimized, virtual subclass registration incurs minor lookup costs. Profile performance critical paths, but typically, type safety and clear interfaces outweigh any performance concerns. Duck typing offers maximum flexibility but lacks formal contracts, catching errors only at runtime. Protocol classes provide structural subtyping for static type checkers without runtime enforcement. Abstract base. Classes offer explicit contracts with runtime validation, ideal for frameworks and large code bases needing guaranteed interfaces. Each approach serves different needs, balancing flexibility and safety. Begin by importing ABC and abstract method from Python's ABC module. Inherit from ABC to create your abstract base class. Decorate methods with a abstract method to define required interfaces. Implement concrete subclasses fulfilling these methods. Test by attempting instantiation to ensure enforcement. Practice by creating a media player class with play, pause, stop, and supported formats. Then implement audio player and video player subclasses.